Bismillahirrahmanirrahim. Welcome to Chemistry 9th, and this is lesson for week 3 starting from 20th April to 24th April 2020. We are starting in this week with chapter number 4, that is about the structure of molecules. We'll talk about bonding, types of bonds in this chapter. The scheme of lesson for this week is, this lesson is going to include 3 subtopics covering 5 number of periods. The written assignments associated are 3 with 1 weekend task. Let's talk about the weekly distribution of the tasks. Topic-wise distribution on daily basis is given to you, and assigned tasks for each respective subtopic have been allocated, and the additional resources are given to you to click on for extending your understanding for each topic. Let's talk about objectives, lesson objectives of this week. By the end of this lesson, students will be able to define stability of an atom, define octet and duplet rule, suggest ways followed by elements for attaining stability, define chemical bond, stating ionic bond and giving its formation with the help of an example, drawing the formation of cations and anions, defining covalent bonds and showing the formation of covalent bonds in different molecules, differentiate between different types of covalent bonds, drawing dot and cross structures of given covalent compounds. Last but not the least, differentiate between polar covalent compounds and non-polar covalent compounds. Okay, let's move now to the next topic, that is 4.1. 4.1 is about why do atoms react? Why there is a need for atoms to react? The need of atoms to react is basically to attain stable electronic configuration. Stable electronic configuration is just like noble gases. The noble gases have complete outermost shell. Their outermost shell is complete by having 8 or 2 electrons in the last shell. Noble gases belongs to group 8A, and with this complete valence shell, they are said to be stable. The valence shell is complete by having 2 electrons in outermost shell, just like helium, and 8 electrons in outermost shell, just like argon, neon, and other noble gases of group 8A. If an element tries to attain noble gas electronic configuration just like helium, that is of 2 electrons in outermost shell, then that element is said to be following duplet rule. I repeat that if 2 electrons an element is trying to attain, for example, hydrogen is struggling to attain electronic configuration of helium, it is said to be following duplet rule. Whereas if an element is trying to attain 8 electrons in outermost shell, just like argon, neon, it is said to be following octet rule. Octet rule, as the name indicate, octet rule means that having 8, octa stands for 8, so octet rule is followed by elements, certain elements, and this is all about game of stability. The whole struggle involves because they are trying to attain, all elements are trying to attain stability, and they are copying noble gases. Let's talk about 4.2 now. Moving to 4.2, that is about chemical bond. Let's define chemical bond is defined as force of attraction that holds 2 or more than 2 atoms together. So, for example, if we talk about an HCl, hydrogen chloride, hydrogen and chlorine existing together. Two atoms are held together with the help of a bond. This bond is called chemical bond. Similarly, another example, NaCl, sodium and chlorine held together by chemical bond. Now let's talk about types of chemical bonds. There are two major types of bonds and other types are also with it. Let's see. Major types are ionic bond and covalent bond. Ionic bond actually is between metals and non-metals. If a bond or attractive forces are held together between metal, non-metal are ionic, and if non-metal are held together, then that is covalent bond. The metal and non-metal ionic bonds, metals form cations and non-metals they form anions, and these are held together by ionic forces of attraction or electrostatic forces of attraction. Whereas covalent is between non-metal and non-metals. There are two other types, coordinate covalent bond, and that is also called the tip covalent bond, and metallic bond. We'll also talk about them by the end of this lesson. Okay, let's move now to the next topic, that is ionic bond. Ionic bond is defined as, it is also called as an electrovalent bond, and it is the electrostatic forces of attraction that are holding oppositely charged ions. As previously told, oppositely charged ions are cations and anions. Cations are positively charged, whereas anions are negatively charged. Cations are formed due to loss of electrons. Anions are formed due to gain of electrons. So, when the cations and anions held together by strong electrostatic forces, this is called ionic bonding. Similarly, we can also define an ionic bond by complete transfer of an electron from one atom to another. The one which is losing is cation and the one which is gaining is an anion. Okay, let's come to an example. Here you people are shown an example for the formation of sodium chloride, an ionic compound, and it is a very common example. Let's see sodium atom first. Sodium atom belongs to group 1A, and belonging to group 1A results or tells us that it has one electron in outermost shell. See its electronic configuration given: 1s2, 2s2, 2p6, 3s1. The last subshell is having one electron, 3s1. Whereas if we look at chlorine atom, it is non-metal, and as a result of loss of this last electron from sodium, it will result in the formation of sodium ion. Whereas chlorine atom belongs to 7A. 7A tells us that it has 7 electrons in outermost shell. See its electronic configuration, and 7 electrons in last shell. The try of chlorine is that it should form a chloride ion by gaining an electron to complete its octet. See, the octet of chloride has been completed after gaining one electron from sodium, and the octet of sodium ion is also complete after losing the last electron. You can compare both the ions, and we will draw the ions by drawing a bar bracket around an ionic form. There is a difference in the atomic form of the elements and writing the ionic form. The ions will be having bar brackets with sign of the respective charge on them. Sodium has lost one electron, and this one electron has been gained by chloride ion. So plus one, sodium carries +1 and chloride ion carries -1, and both of them are held together in ionic compound. Let's talk about KCl now. Another example, see potassium, it also belongs to 1A, and when it belongs to 1A, it has one electron in last shell. So this one electron in the last shell is here, you can see in the last shell, and it will be transferred to chlorine when they will form a ionic compound. So potassium will lose the last electron, and see chlorine, it has 7 electrons in the last shell, and if 7 electrons are there in last shell, it will gain 1 electron more to complete its octet, and sodium and potassium will lose 1 electron to complete its octet. See the comparison between potassium ion and potassium atom and potassium ion. See the electronic configuration shown, 288 after ion formation. This is cation formed by potassium, and anion formed by chlorine. Chloride ion is formed. So after forming ion, chloride is having 8 electrons in outermost shell, and after forming potassium ion, once again octet has been achieved. So this is how stability is gained by the atoms by loss and gain of electrons respectively. So loss and gain of electrons is important to understand. Let's talk about another example, that is calcium sulfide, formation of calcium sulfide. Once again we'll do some rough work first, rough calculations. See the formula of calcium, that is calcium sulfide. Just a minute. So here I am going to continue with that. Calcium sulfide. Calcium belongs to group 2A and sulfur belongs to group 6A. So my calculations, I should be first doing my calculations that how the cation and anion formation will take place. Calcium belongs to 2A, so it is a metal. It will lose 2 electrons because it's having 2 electrons in the last shell, and after losing 2 electrons it should form a cation of +2 type. All right, if you people are following me, calcium is a metal. Let's talk about sulfur. Sulfur belongs to 6A. So if it belongs to 6A, it means it has 6 electrons of its own in last shell, and if it has 6 electrons of its own shells, it needs 2 more to complete its octet. So it will gain 2 electrons and form an anion, because gain of electron results in anionic formation. So -2 charge will be there because 2 electrons will be gained. Let's see the illustration now. Calcium changes to, look at the electronic configuration of calcium atom, 2882, and look at the electronic configuration of ion, 288, completed 8 electrons after losing. And similarly sulfur changes to sulfide ion, and 2 electrons which are lost by calcium are gained by sulfur, and it forms -2 type of anion, and calcium forms +2 type of cation. Look at the electronic configuration of sulfide. Octet is completed by the end of this bonding. So stability is successfully attained. This is, once again, the whole game is about stability. Let's talk about magnesium. Magnesium belongs to group 2A. Chlorine belongs to 7A. So magnesium is a metal, and it will lose 2 electrons in last shell, whereas sodium is a non-metal, but it needs to gain 1 electron. So there is a now difference. The loss of electron is 2, gain is 1. So we need to balance the net loss of electrons and net gain of electrons. So magnesium will lose 2 electrons, +2 sign will be there. and each of the lost electron will be given to each chlorine atom. So there must be 2 chlorine atoms approaching to bond with one magnesium to form chloride. Each chlorine will be converted to chloride ion by gaining 1 electron, and the formula will be magnesium chloride, MgCl2. So this is how the bonding of MgCl2 is taking place.